Hello everybody, my name is Mohammed Riyad Abbas, studying at Middle Technical University in Baghdad, Iraq. I am presenting today the paper titled I2Text Communication Based on Human-Computer Interface Method. Okay, the first is the introduction. The development of I2Text communication devices has become a helpful resource for people with speech impairments. These systems use computer vision to monitor eye movement and translate it into meaningful text. OpenCV provides processing and analyzing for photos and videos, and DLib offers powerful algorithms for selecting facial landmarks, materials, and methods. The purposed system describes the hardware used and the algorithm in the following sections. First, proposed system. The suggested system consists of the components depicted in figure, which include person, camera, Raspberry Pi 3, and display screen. The camera is positioned on the person's head to avoid any head motion and to measure the space between the face and the camera. The algorithm DLib chooses distance of between 20 and 70 centimeters from a person's face before recording to identify facial landmarks in real time. The test found that 30 centimeters is the optimal distance to detect facial landmarks in real time. Second, proposed algorithm. The method is divided into several basic states. At the start, the software initializes to capture video frame from the webcam. The system recognizes the user's face in the video and converts the image to grayscale to aid facial landmarks detection, as shown in the flowchart in figure. Face detection techniques using OpenCV and DLib libraries. The system then uses gaze estimation methods to follow the user eyes in real time. The ratio of blanks and gaze will be calculated from the calculated eye tracking algorithms. If the eye aspect ratio is less than 0.20, then blanking was identified at the time as the output of the data set. The eye gaze ratio will be added to the data set if it falls within the range of white pixel greater than or equal to 0.2 and less than or equal to 5. In the end, the operational system stops when they end a video to exit loop. Second, first, load capture a video. Video captured using a webcam consists of 30 frames per second. The appearance is graded by age movement in the person's eyes and implementing the while loop to load frame in a valid state and end video in case of error loading as shown in figure. Second, Second, face detection. DLib library is used for 68 fixed locations on the face for anyone who serves as a marker. The predictor in for loop loads each frame from the video and detects face landmarks within the image as shown in figure. A digital image on screen is presented through a matrix of pixels, which the image pixels. The numerical value range from 0, which represents black pixels, to 255, which represented white pixel. Note that OpenCV tends to load color image in reverse order, specifically PGR as shown in figure. Once face or landmarks is discovered, that be used to generate new landmarks inside the loop to convert the color image to grayscale image as shown in figure. 2.3 detects eye blinking based on webcam using DLib. To identify blinking, it is necessary first to determine the facial landmarks of the eye and then compute the eye aspect ratio between the landmarks of the eyelids, selecting landmarks for the eye region left 36 to 41 with the eye region right 42 to 47 as shown in figure. The eye can be described as collection of 6 points. Distances are measured in both the horizontal and vertical planes, including the left eye's horizontal line length is distance between point 36 and 39, and the left eye's vertical line length is the halfway point between point 37 and 38 and between points 40 and 41. The horizontal line length for the right eye is the distance between point 42 and 45, while the vertical line length is the midpoint between points 43 and 44 and between points 46 and 47. After that, the ratio of blinking is calculated from equations. Second, fourth, detect eye gaze tracking in video using OpenCV2. Identifying and analyzing the eye image consists of 3 primary parts. The first part of each person's eye is called the pupil, which appears as a black circle in the center eye. The second part of the eye is called the iris, which refers to the most extensive circle of the eye, which can be variety of color depending on the person. The final portion, the sclera, because it is always white, can be used to track the eyes to determine the number of white retinal pixels as shown in figure. When look left, the sclera covers the eye on the right side on the pupil and iris and locate on the other side left. The rest is with the same work as shown in figure. Using the NumPy library, polygonal outline is drawn around the eye region that includes the sclera, the iris, and the pupil to create matrix with 6 points for the eye landmarks. The next step is to make a black mask that completely fills the image and then draw polygon over the eyes on the mask. This will allow the extraction of the eyes using the bitwise and binary pixel, which combine the grayscale image with the polygonal black mask image to filter out things like eyelashes and lashes with threshold accuracy of 70 pixels as shown in figure. Questions demonstrate how to calculate the ratio of gaze for white pixels in real time by gathering up all the white pixels on the left and dividing all the white pixels on the right. After that, the ratio eye gaze is determined for one eye, and the result is divided by 2 to obtain the ratio gaze. Second, fifth, display screen based graphical user interface. Indict eye movements as left gaze water, right gaze food, top gaze bathroom, bottom gaze sleep, blink pen, and center gaze none. Moreover, a review on display screen employing GUI assists the healthcare provider with the requirements and needs of the patient, as shown in figure. Results: 1. Eye blocking using the DLib library. The x-axis frames will y-axis ratio, eye aspect ratio. 2. Eye gaze tracking using the OpenCV library. The x-axis frame and will y-axis ratio eye gaze tracking. Conclusion: people with speech or movement impairments can benefit from eye gaze tracking technology. In this paper, we present the result of the proposed eye tracking system of eye text communication, which consists of a camera, Raspberry Pi 3, and display screen that use the face and eye detection algorithms, the OpenCV and DLib. The OpenCV algorithm sclera pixel count was used to determine the gazing ratio, while the DLib algorithm's facial feature points were used to determine the blocking ratio. After that, information was inserted from the right, left, top, bottom, and blocking on the Excel sheet. Thank you for your listening.